Action potential, calcium. Bio Ninja was useless. I can't study these assessment statements. I mean, I can't do it again. I wrote a letter on the last test. I didn't even write an answer. Who am I kidding? You know, it'll come to me. I just have to sleep it off. Ping pong club at D12. What was that? It was just a dream. It was nothing. Who's breathing? What? Who's that? Oh. What? Oh man, this bio test is getting me. This is awful. I need to go back to bed. Ping pong club on the 16th. What? Who is messing with me? I just need to get rest. What was that? This is just in my head. I need to go to sleep. Okay. This is nothing. This is nothing. I just gotta get some sleep. I have a big test tomorrow. What? Who turned on the light? What? Who? Mr. Smith, why are you doing this to me? I didn't ask for it. Please, just leave my home. Please, it's a dream. It's a what? Where'd he go? Mr. Smith, why are you here? I'm studying for my test.
Not ready for your bio test, Jack.
No, I am.
Ping pong club Wednesdays and Thursdays.
Okay. What? Please, it's 2 a.m., Mr. Smith.
Do you know what a mycofibrin is, Jack?
Can you teach me?
Lay down. I can.
Okay.
That's why I'm here.
Alright, I gotta be over at Stanley's in an hour. I'm a busy man, so I'm only giving the outline. Alright, this is some of the flow chart for the muscle contractions, and one of the main parts that you need to know is how does the message from motor neurons cause the muscles to contract? And essentially what that does, it happens a little bit earlier, is when the nervous system signal, sorry, I have a cold, reaches the neuromuscular junction, a chemical message is released by the motor neuron. This is in position of the origin of whatever the pulling is. And the chemical message and neurotransmitter binds to receptors on the outside of the muscle fiber.
Okay, I didn't know that's how it works. Thank you. But also I have a question about like sarcomeres. Like, how do they work, or like how do they contribute with muscle contraction?
So, sorry, I have a cold. So I'm glad you asked, because sarcomeres are pretty important, because each muscle cell does contain thousands of these, and they work together to cause a muscle to contract by essentially when a muscle contracts, the actin is pulled along myosin towards the center of the sarcomere until the actin and myosin filaments are pretty much completely overlapped. And essentially what this means, kind of shown in this diagram and throughout the process, is for a muscle to contract, the sarcomere must shorten, and thick and thin filaments do not shorten. This is what the diagram shows here.
Okay, thanks. But so I heard that there's like calcium ions and like ATP and stuff. How does that work?
All right, so basically, like you said, calcium and ATP are used for multiple things, but calcium is basically used to start the cycle that I'm about to explain. The muscle contraction cycle is triggered by calcium ions and by binding to the protein complex, exposing the active binding sites on the actin, also exposing myosin binding sites, and ATP can then attach to myosin, which allows the cross-bridge cycle to start again, and further muscle contraction can occur. So it starts at the end and then ends, and ATP can restart it. ATP, like I said, then binds to it. It moves the myosin to its high energy state, releasing the myosin head from the actin active site, and and it starts the cycle again, and yes.
Thanks, Mr. Smith. That really helped. Oh, and hey, Mr. Smith, don't come to my house again, please. Good night.